Hi, my name is Frank Ball, Director of Communications Infrastructure here at SoftChoice, and I'd like to talk to you about some really cool things that are happening in the data center today. Now, a lot of our customers we see going down the virtualization path is a form of workload consolidation. So, traditional customers got 1,000 servers and they're trying to collapse and consolidate down to, traditionally a 10-to-1 consolidation ratio of 100 servers to support that same workload. What we find is a lot of customers aren't keeping up to date on some of the changes that are going on in networking inside the data center. So I want to try and talk to you a little bit about that today. So the first thing is we have to understand is as we start to virtualize, we're really looking at the consolidation of CPU and memory that we're going to take advantage of on these virtual hosts. One thing a lot of customers forget to look at is what is the constraints on I/O. And by the way, you don't want to find out the hard way and be oversubscribed and have an application hiccup, especially if you're in the middle of a backup or window or something. So one of the things that we do as a company is a traditional I/O assessment, so we can kind of start to map out what the requirements are. So if I'm going to collapse and consolidate my environment from 1,000 servers down to 100 physical servers, 1,000 virtual still, and I'm looking at a consolidation ratio of 10-to-1. Let's just do simple math. Let's say that I've got 10 rows of 10 racks inside my data center floor, and I'm going to bring all that into one row of 10 racks. Let's look at the minimum I/O connectivity when I want to go with vSphere and take advantage of high availability and fault tolerance. Now, for giggles and grins, let's just start by saying I know that not all applications lend themselves to virtualization, so we're just going to go with round numbers to paint a picture for you. So if I'm looking at 10 racks, and I've got basically 10 servers per rack, I'm looking at a total of 600 IP connections just on my IP network. How do I get there? Well, if I'm running high availability and fault tolerance, the minimum connectivity per physical server is 6 NICs. 2 for I/O, redundant to 2 sets of switches. 2 for management, redundant to 2 sets of switches. Then on my storage fabric, I'm going to have 2 HBAs that are going to connect into basically my fiber channel or iSCSI switches that I have out there. So if I do the math on exactly how many ports I need, I'm going to need 600 ports for IP connectivity and 200 ports for my storage connectivity. Well, here's the problem. Switches don't come in round numbers. So really, if I'm going top of rack, bottom of row type scenario, top of rack being my I/O for my IP network and bottom of rack being for my storage network, I'm going to end up with basically 2 48-port switches per rack to be able to support the connectivity, and 2 24-port switches bottom of rack to support my SAN connectivity. That's going to give me a total of 960 ports top of rack and 480 bottom of rack. By the way, every single one of those switches, of which I'm going to have 40, I've got to manage, monitor, control, pay maintenance support on, cable, and power. It's a problem, right? So what the manufacturers did is they got together and they said, there's got to be a better way. About 1.5 years ago, the ANSI T11 board ratified this new standard called Data Center Bridging, or DCBX. It's commonly what it's called today. And what this is, it's a rewrite of the entire application protocol stack inside of the data center floor for Ether. To take advantage of the standard, I need a couple things. The first thing I need is a converged network adapter. The converged network adapter would go directly inside of my host or my server, and it replaces basically my fiber channel HBAs or my iSCSI HBAs and my IP connectivity. Well, I want to run redundant pairs, so I would have 2 of these for an aggregated throughput of 20 gig that I would now run out and I would connect to my Nexus switches. And Cisco's Nexus 5000 is a product line that we're going to focus on today. Nexus 5000 basically comes in two different configurations, the 5010 and the 5020. The 5010 has 20 fixed ports of 10 gig data center bridging available to you. All 20 ports. Now the first 8 can do traditional 10 gig, or they can do 1 gig as well. The reason they call it a 5010 is I've got one expansion module over on the right hand side. Now what that expansion module gives me the capability, if I'm running fiber channel in my environment, here's where I can split fiber channel out and aggregate that fiber channel connectivity. If I need more 10 gig connectivity, I've got 8-port 10 gig adapters that I can stick in there and take advantage of. So I end up with 28 total ports available to me. The next model is the 5020. Notice the 5020 is just pretty much twice the size, and I have 2 expansion modules, and I've got 40 ports of basically 10 gig available for data center bridging or data center Ethernet or converged enhanced Ethernet, whichever you wish to call it. So what's the residual effect of all this for you as a customer? Number one, less infrastructure, less CapEx. Number two, I've got less things in my environment that I've got to manage, monitor, control, pay maintenance support on, and provide power for. Right? So I'm going to have less operating expense. And now I get the capability with all these tools being integrated into vCenter that I've got one pane of glass that I can manage the entire data center floor. So those are some things I wanted to talk to you about today. I look forward to talking to you in the future. If you have any questions, make sure you just send an email to askcisco@softchoice.com. Have a great day.